In this example, we observe an electric network. And in this electric circuit, this closed electric circuit, we have a couple of batteries, a 41 volt battery as well as a 51 volt battery, and we have several currents associated with these. At our junctions, these will be places where the currents will come together and travel through the same place or split off into two separate currents. So what we're going to do is try to use Kirchhoff's laws as well as typical electrical network stuff to figure out what is the total amount of current I1, I2, and I3. So first thing we'll do is we'll set up a flow in matches a flow out for each of the two junctions. So for the junction over on the left side, we have current I1 flowing into it based on the arrow that I see, and I3 flowing into it as well. So the flow in is going to be I1 plus I3. The flow out is going to be the current that we see labeled as I2. Now over at the other junction, we see that I2 is flowing in and I1 and I3 are flowing out. So that's honestly just going to give us the same equation, so we don't really need to worry about that. Now, as far as Kirchhoff's laws are concerned, in any of these closed circuits, we need to make sure that the sum of the voltage drops matches whatever the voltage is for the battery. Now, based on the currents that we have, it's going to be resistance times current for each of these. So for the upper loop, I see that we have a total of two different resistors. So if I take the resistance times the current for each of these resistors, it should add up to the voltage for the battery. So for the upper loop, we're going to have a resistance of 2 ohms times current I1 plus the resistance of 5 ohms times current I2. Those two together should match the voltage of the battery that's on that loop. That's 41. For the lower loop, I see once again we have two resistors. We have resistance of, well, let's start with I2. We'll say 5 times I2 plus the resistance of 4 ohms times I3. 4 ohms times I3. That's going to be equal to 51. What we wind up with is this nice little 3x3 system with 3 variables and 3 equations. Now, one of these is going to need to be altered so that we can set up an appropriate matrix. We'll bring the I2 over to the left-hand side of the equation so that we can set up an augmented matrix. So the augmented matrix that we're going to set up, we'll treat the columns as being I1, I2, and I3 with a goal of reduced row echelon form. So first equation we can model using 1, negative 1, 1, and it'll be equal to 0. So augment of 0. For the second equation, we could do 2, 5, and since there is no I3 term, we would use a 0 for that one. Augment is 41. And then finally for the last one, there is no I1 term, so we'll use a 0 for that. 5 for I2, and then 4 for I3. That's going to wind up giving us a voltage of 51. This is what I'd like to take down to reduced row echelon form. So with that in mind, we already have our 1 in the 1, 1 entry. I'd like to zero out the entry below it. So we'll take negative 2 times the first row, add it to the second row. That'll become the new second row. So first row stays the same. Third row stays the same. But the second row is going to change. So take negative 2 times 1, add to 2. Negative 2 times negative 1, add to 5. And negative 2 times 1, add to 0. We'll also take negative 2 times 0, add to 41. Now it's already looking like we're going to get some pretty gross numbers in here if we say introduce some fractions here. But no bother, we're going to suck it up and make it work. So next goal is going to be to get a 1 in this entry right here. There are, I guess, some ways that wouldn't be quite so bad, but we'll take 1/7 of row 2, make that the new row 2. This will, of course, introduce some fractions which are, gross, but we'll make do. So first row stays the same. Second row, we will get 1/7 of each of these entries. And then the third row stays the same. Now that we have our 1 in the 2-2 entry, we're going to use that to zero out the other 2 entries above and below it. So we will take row 2 and add it to row 1, and that'll become the new row 1. And we'll also take -5 times the second row, add to the third row, and that'll become the new third row. So overall, second row is staying the same. And we'll take the second row and add it to the first row. So 0 plus 1, 1 plus -1, -2/7 plus 1, that'll be 5/7. And then we'll take 41/7 plus 0, that'll give us 41/7. All right, now for the super fun part. We'll take -5 times 0, add to 0. -5 times 1, add to 5. -5 times 2/7, that'll be 10/7, plus 28/7, that'll be 38/7. Oh boy, this is already fun. Then we'll take -5 times 41/7, that'd be -205/7. Add that to 51, but we'll get a common denominator for it and call that 357/7. And then we'll just go ahead and add those two things together. That'll be 152/7. Now, that did turn out kind of gross, but the good news is the next operation that we do should fix everything. So we're going to take 7/38 of the third row, and we're going to make that the new third row. Now, the reason that this is really good news is because 38 goes into 152 exactly 4 times. So I'm going to do a little bit of, let's see, what can I do here? Let's try like this. Yes. So I want to, sorry, I'm off camera. I want to recopy this onto the back of the page. And I don't want to have to keep flipping back and forth. So first row stays the same. This is 1, 0, 5/7, 41/7. Then we have 0, 1, -2/7, and 41/7. And finally we'll have 0, 0, 1, 4. Good news for us. Let's go ahead and alter this a little bit. There we go. So this is what we wind up with. Next, we'll use the lead 1 in the third row to zero out the 2 entries above it. So this will be the last operation that we'll need to do, though it will be kind of painful. We'll take 2/7 of the third row, add it to the second row. That'll become the new second row. And we'll take -5/7 times the third row, and we'll add that to the first row to create the new first row. I'm hoping that everything is going to go super well when we do this. Alright, so overall these entries are going to stay the same. These 2 entries are going to wind up being 0 and 0. Then we'll take we'll take 2/7 times 4, so that's 8/7. Add that here, we get 49/7. 49/7 is 7. That's good news. Then we'll take -5/7 times 4, that's -20/7. Plus 41/7 is 21/7. 21/7 reduces down to 3. Fantastic. So this tells us that current I1 would be equal to 3 amperes. Current I2 would be equal to 7 amperes. And current I3 is equal to 4 amperes. There was probably a cleaner way to do that reduced row echelon form, and if you can find it and you want a suggestion, please feel free to leave a comment. Yeah.